Hello, welcome to Intro to Computing. I should say Intro to Programming. This week we're going to be talking about objects in Python. Objects are a data structure that exists in Python and most other languages. And we've actually been using objects almost since the beginning of the course, even though we haven't really dived into them or discussed them much. In Python, almost everything is an object. All of the data types, numbers, strings, lists, data, dictionaries, even functions are actually objects. And so we'll kind of learn how they work, and you'll understand a little bit more about how we've used them in the past, I hope, after we finish this chapter. So what we've been doing so far is essentially called procedural programming. And in procedural programming, we have procedures, which is really another name for a function. We have functions, and then we have data, and they're separated, right? There's really there's nothing to join the data and the functions except by the way we use it. So if we pass a data item to a function, you know, they go together, but we have to enforce that ourselves. An object is a way of combining the functionality of something with the data that goes with it. And it makes it a lot easier to, excuse me, it makes it a lot easier to sort of keep track of things when we do it that way, because we can have a single entity that has all of the things we need for that entity put together under a single name that we can easily use in our programs. So the word object comes from really our everyday world, where we have lots of objects. For example, a pencil, a car, a dog, a house, a cell phone. These are all objects that we interact with. An object is usually a noun. It's usually a thing, although it can also be a kind of an abstract concept. Objects have properties, and they perform actions. Property is a feature of the object, such as the size or color and weight. A property is usually a noun. An action is something that the object can do or that can be done with an object. So an action is usually a verb. A pencil can be used to draw, a car can be steered, braked, and accelerated, and a dog can bark and walk. So these are ways to describe objects in the world. An object in Python is similar, except our properties are variables and our actions are functions. And we put the functions and we put the variables together under a single named entity that's an object, and then we can use it. Okay, so before we have an object, we have something called a class. So class is a class defines an object. So it defines the set of functions that the object has. It defines the data that the object has, and it defines other things about itself, such as its name and other things that we won't get into because they're a little too complex for this class. Okay, so a class is very much like a function. Okay, a function it defines a piece of software that we can run, but a function doesn't do anything until we call it, right? So if you have functions defined in your program, but you don't call them, those functions are never sort of active. They don't do anything. They just kind of sit there in the code and aren't used until you actually call them. So classes like that, when you define a class, it doesn't do anything until you create an instance of the class, which is what is actually, the object is actually the instance of a class. So a class is kind of like a blueprint to a house, where it's just, it shows what the house looks like, right? It shows all the features of the house, but it's obviously, it's not the actual house. It's a definition or description of the house. Okay, so let's get into an actual class here, and hopefully it will become a little clearer. So let's imagine that we want a class called dog, which sort of encapsulates the things about a dog that we care about in our program. So this is the code on the page here is a class definition of a class that's called dog. So notice we have the keyword class and then the name. The name follows the same rules that we have for variables, but by tradition, Python classes generally start with an uppercase letter. It's not required, but usually that's what you'll see if you look at Python code, is classes will have a capital letter in starting, you know, the name is capitalized. Then you have a colon, and then we have definitions. We have basically function definitions. And notice that it's indented, that's important. That's how we know that a function belongs to a class, is it's indented under the class keyword. These functions have slightly different rules than the functions that we've talked about so far. And yeah, I guess we can get into that now. So let's just start the first one here. So this first one, which has sort of a strange name, underscore underscore init underscore underscore. This is a special function that gets called when you create an instance of the class. In other words, you create an object of this class. For all function definitions, for our purposes, we have this keyword called self, and that's important. That's important to show that the function that we're making is actually a part of the class that we're making. It's part of the instance of the class. There's a type of function called a class function that we're not going to get into. It's a little bit too advanced, but for our purposes, we always have something called self, a parameter, and self is the way that inside the object we refer to the object itself, right? And you can see underneath here, self.breed, self.color, self.weight. Okay, the self is a way to reference the object that we're building. All right. So later on, we can access these variables from other functions. So the rest of the function definition is what we're familiar with, where we just have a bunch of parameters that are defined. So we have the breed, color, and weight, followed by colon, and then we have the code that implements the function. Okay. And so all we're doing in this special function, init, which also has the name constructor. It's a special word that denotes the function that gets called when you create an instance of the class. It's kind of a mouthful, but what it means is that when you create an object, you can set it up in a certain way. So when you create an instance of dog, you can define the breed, color, and weight, and you can add as many of these parameters as you like, or you can have none at all. And all we're doing is saving the values that we pass in so that we can use them later. Okay, so we're assigning them to this self variable, So you can sort of think of self as a variable that belongs to this object, okay? And this is a very typical constructor. It's very typical that we pass in variables that will define the object that, you know, we're going to use these things later on. So the next function here, it's called bark, okay? And this is going to do something with this object. So as this is a dog, we're going to print rough rough. Now this could be, you know, this could actually play a sound, you know, of a dog barking, or it could, you know, play a video, or it just depends how you implement this object, right? Bark could do a lot of different things, but we're just going to keep it simple. It's just going to print a message here, okay? And then we have three functions called get underscore name. Okay, so we got get breed, get set weight, and get weight. What these do is these interact with the variables inside or that are part of the function, okay? So we generally want to access the variables or the properties of an object via functions. That way, we can enforce rules about them if we want. We can add code. For example, we'd probably want some code that checks to see that the breed is valid, for example, okay? So if someone passed in a breed name of A, B, C, D, E, F, G, well, that wouldn't make any sense, right? So we might have some way of checking that the breed is a valid breed. Maybe we have a table or a list of acceptable breeds from, you know, the American Kennel Association or what have you. And if a person passes in a breed that isn't valid, then we could raise an exception. And the same with the weight, for example. You know, we might have obviously a weight couldn't be less than 0, and it wouldn't be greater than, you know, 200 pounds or something like that. So we prefer not to, even though technically we could access these variables, and I'll show you that later on. We generally want to have these things, these get and set functions, which are usually called getters and setters. The book calls them something else, accessors. Just bear with me for a second here. Sorry, I should have looked this up beforehand. Accessor and mutator methods. Okay, so an accessor method would allow you to get the value, and a mutator would allow you to change it. Okay, they're often called getters and setters because they usually have the format get name or get underscore name and set or set underscore name. And this is in most languages have the same kind of a concept. Okay, so I think we've talked about all these things. Okay, before we get to, okay, let's talk about a couple more things before we look at an example. So this concept of how we combine the functions and the data in an object is called encapsulation. And that just means, the word encapsulation means we're sort of putting everything into a kind of a bundle, right? We're boxing it up into a single thing that we can access. Okay, we talked about the getters and setters, which is a way to interact with these variables, also called instance variables, because when we create an instance of the class, we also get these variables. Okay, so that describes the class and how we make a class. Now, how do we create an instance of the class, or in other words, how do we create an object? Right, another word for creating an object is called instantiation. It's a fancy word for creating an instance of. All right. So on this dog class, we have 3 arguments: the breed, the color, and the weight. So the way that we create an instance is we type in the name of the class, and then parentheses, and then we pass in the arguments for the init function or the constructor. So it's very much like calling a function. Okay, creating an instance of a class is very much like creating a function, and it's important that we assign that to a variable. Otherwise, if we don't do that, we won't be able to get access to that object. It will create it, but it will essentially be lost to us because we're not saving it to a variable, which in this case is my dog. Okay, so what happens when we do this, we create an instance of the dog class, right? It actually calls the init method, which we looked at earlier, and it passes in these arguments, boxer, brown, and 25. And then it returns, it creates it sets up that object, it creates memory for it, and it assigns the variables. We go up and look at that again. It assigns the values for the arguments to this variable self, and then it returns that value. Okay. So let's go ahead and do some examples here. Okay, so I will do basically the same thing that was in the notes. And I may think I'll just have a couple of parameters instead of all of them. Let's just do breed and color. Right, and don't forget self, it's very important. And then we save the values like this. Okay, so in the book, the way that they do this is the object variables or instance variables start with double underscores. And that's just kind of a notation that you can use if you want. So that's a pretty common notation. Another common notation is 1 underscore. But that's really up to you. Or if you're working for a company, you know, they might have standards for that sort of thing. So they may ask you to do it a certain way. Generally, when I'm writing Python code, if I'm writing it from scratch, okay, I'm probably not going to use the underscores. That's just sort of my personal preference. But if it's someone else's code, which is, you know, it's a very common thing that you're going to be working with someone else's code, I'll use the same way. I'll do it the same way they do it. Okay, so if they have object variables that look like this with a double underscore, I'll do the same thing. Okay, you want the code to be consistent. Regardless of how you write the code, you want it to be consistent with all the other code that is around it. Okay, you don't want to create some brand new, you know, standard just because you like it. You want it to be consistent. Okay, so I'm just going to do it this way, but keep in mind that you can do it how you want, and it doesn't matter to me. Okay. Let's say that it's do it like that. Okay, and then we're going to make a getter and a setter. Get breed. What that's going to do, we always want to return self.breed, which is what we have saved from above. We want to be able to, so in this case, it probably doesn't make sense to have a setter because we're probably, we're not going to change the breed of a dog probably after we've created it. We're probably not going to change the color, okay? The weight, on the other hand, if we had the weight, then that would make sense because the weight is going to vary. The color and the breed is probably not going to vary, okay? But just to show you how it's done, okay? Again, we always have self. Then we have the parameter, and then we'll say self.breed equals breed. It's kind of, again, another personal preference. If you have spaces between or surrounding the equality sign or not, it's up to you. Okay, so I'm just going to do a getter and a setter for that one, just in the for brevity here. Okay, so that's our class defined. Let's run the code and see if we get any errors. It looks like it worked. Now it's not doing anything. Right, that is just a definition. So in order to get it to do something, we have to create an instance of the class, and we do it like this. Okay, now remember that Python is case sensitive, so a small letter D dog is a different name than a capital D dog. And this is a pretty common convention where you'll create a variable with the same name as the class, but with a lowercase letter, right? But it's not in any way required. We could call it my dog if we wanted. Okay, so we'll just call it my dog. Now, if I don't pass in the parameters defined in the constructor, I'm going to get an error. So let's go ahead and try that. So it says type error, init missing 2 required positional arguments, breed and color. Well, that makes sense because we don't have these here. Okay, so I'll put in the breed, a Dalmatian. We can just do it this way if we like, it's fine. Okay, so now we have an instance of this and we can run it. Still, so now we actually have an instance of this object. Well, the object is my dog. So we actually have an object now called my dog. So now that we have my dog, we can actually start doing things. Okay, so we can say my dog.getBreed. And we can assign that to a variable. Yeah, we can print it. And so what should print is Dalmatian, and it does. Okay. So let's use the setter. Okay, and again, probably doesn't make sense to change the breed necessarily, but we're going to do it anyways. So we're going to change it from a Dalmatian to a poodle. And we're going to, again, we're just going to print the breed, get breed. This time we should see 2 different breeds, and we do. Okay, so that's our first object. Our first class is dog. Our first object is my dog. All right, so we'll get back to the notes. So one other thing to mention here is this shows how to access the instance variables. Okay, so instead of calling these getters and setters, okay, we actually can just set those things directly. So we can print my dog dot breed. Okay, this isn't a function call, right? Because it's not, the functions are get breed and set breed. We're actually accessing these variables directly. Okay, and you can see it prints out Dalmatian. So I'm just gonna emphasize that generally we don't want to do that because it invites people that are going to use our classes to kind of mess around with things inside. So the concept of encapsulation is we want to create this thing that people use in a certain way, right? So if the user of the object or the class starts directly changing variables, then they might very well mess up how the class is supposed to work. Okay, so we want to avoid that. We want to provide a means for the user of the object or the class to interact with the class in a way that we want them to, using these getters and setters. Because again, we might have some rules in there that define what you can actually do, so that we don't want them to set an invalid breed or invalid weight or invalid color. Okay, and we can do that as long as we provide the function or the interface to the object. Okay, it's not illegal, and there's reasons to do this, but for our purposes, we're gonna stick to interacting with an object through the functions, or another word for a function of an object is a method. Okay. All right, so I think we've kind of gone over how to use an object, how to create an object. Okay, so this is kind of important, that if we have, let's go back to our code here. Okay, so we have an object called my dog. So if we do this, okay, so if let's create another object. If we say your dog equals my dog, okay, do we have two separate objects? Well, the answer is no. Okay, it's not like with something like an integer or a floating point value, we can actually do that, and we're actually creating two separate instances of that variable or that number, if it's an integer, let's say. This is just creating a variable that references the other object. So let me show you what I mean by that. Okay. Let's say we change the breed on this dog. Okay, we're going to change it to a Labrador Retriever. Okay, so if we print my dog.get breed, it's going to print Labrador Retriever. Not sure I spelled retriever wrong. We're right, but anyway. Well, now what happens if we print your dog.get breed? So if these were actually two different independent objects, your dog would still be the same as the original value, right? Because originally the breed was Dalmatian, and if we set your dog to that object, it would be still Dalmatian after we set my dog here. But what you're going to see is they're both going to be actually the same. Okay. So they're exactly the same. So they're pointing to the same memory location, right? And this may come up if you think you're making you want another copy of an object. You can't do it that way. Okay, you have to basically either instantiate another copy of the object or of the class, or you can actually do this, but then you're going to have to set the values as you want them to be. Which actually that's not going to work either, because ultimately they're both. So I'll take that back. The only way to really do it is you have to create another instance of dog, okay, and put the values that you want in there. I won't put them in there, but now we have two separate objects with different pointing to different locations in memory that is storing the values or the variables for the object. Okay, so just something that could confuse you at some point if you think that assigning a new variable to a new an object is going to get you a different copy of the object it actually isn't. Okay. All right, so I don't think we'll do this first exercise because this is very similar to what we did with the dog class. But this one I think we will do. So problem 2, create a class called my list that has a constructor, which is the init method with no parameters. My list has a method called add that adds an integer value to a list owned by the object, and a method called average that returns the average value of the elements in the list. Then create an instance of the class, call add a few times and call average. Okay, so let's do that. Let's just delete all this stuff. Okay, we're going to create a class called my list, and we need a constructor init. Okay, and okay, there's no parameters to this, but what we need to do, well, actually, I take that back. There's always the self parameter, even if there's nothing that we're passing to it. Right. So what we're going to do inside here is we're going to create a list to store these values that the user, the creator of the object, is going to give to us. Okay. So let's just call it. Let's see. Let's just call it numbers, and this is we're assigning the value of the variable numbers to be a list, an empty list. Okay, so then it says create a function called add. Okay, and we're going to have a value parameter, and what we're going to do is we're going to append that value to the end of the list. Okay, and we need another method called average that averages those and returns it. Okay, so we have a method called average. Okay, and what that's going to do is return the average. So we can take advantage of the sum method, which we learned about a couple weeks ago, I think. So that should give the sum of all of the elements or items in this list. Okay, and then the average equals total divided by self. So we need to know how many items are in the list, that we can get that from the length function. Okay, and we're going to return this variable AVE. All right, let's just see if this compiles. So I often forget to pert the self parameter. Okay, so don't feel bad if you do the same thing. Okay, no errors. So I'm going to create a instance of my list like this. Get the equality sign. Okay. All right, so let's add some numbers. We'll add 10. We'll add 5. And we'll add 5. So the average, let's do another one just to make the average easy. Okay, so we're adding up to, since we have 4 numbers, let's make it an even number. Let's say that should add up to 20. Okay. And then let's print out the average and the average should be 5 if my math is correct here. Yep, it worked. Okay, so every time we call the add function, what that's doing is adding and appending that number that we pass in to the end of this list. And it just keeps doing that as long as we call add. And then when we call average, what it does is it gets the average of all those values and returns them. Okay. So this is, this is a pretty common thing where maybe we want to add another function to, a Python list, right? So one way to do it is to create our own object to add some functionality to it, and then we can create an instance of that object, and it's very convenient to use. Okay, so and we can add as many methods as we want. We can add as much instance variables as we want. We only have one here called numbers, but the sky's the limit really for once you create an object, you can add all this functionality, and then it's completely self-contained within that object. And other, you can publish that object or publish that class, and other people can use it in any way that they want. So with just functions, it's kind of hard to do that because there's a relationship between the data and the functions, and if you don't have an object, it's pretty hard to manage all that stuff. Okay, so objects are a great way to design your program to where you can really keep track of all the data and all the functionality that goes along with the data. Okay, so at the beginning I said that everything in Python is an object. An example of that is a string. Okay, so and a list, but we'll go to strings here. So if we have a string, we've created strings before, and we've treated them basically as variables where you can essentially print a string, you can concatenate strings, and you can do other things with strings. But there's also a lot of functions associated with strings, and we have talked about a few of them, such as the upper function. So what we're actually doing here, and again, the notation is different. It's different than what I just showed you, but in reality, a string is just an object. So string 1 is an instance of a string. We have all of these functions associated with it, such as upper and lower, and find, and replace, and the things we talked about in the string chapter. Okay. And if we want to know all of the methods and all of the instance variables associated with an object, there's a useful built-in function called dir, which stands for directory, and that will show all that stuff. Okay, so let me create a Python console here, and I'm just going to create a string. Right. So if we pass this variable to the directory function, we'll see it'll print out all of the methods that a string has, and it'll also print out if there's any instance variables that are associated with that object as well. So for example, starts with is a function that I think we might have talked about a bit. So we can call starts with, and that just returns true if a string starts with the substring that you pass to it. So since our string, okay, well, it's 1, 2, 3. Does it start with the letter A? It does not. Does it start with a 1? Yes. Does it start with a 1, 2? Yes. Start with the 1, 2, 3. Yes. Start with the 1, 2, 3, 4. No, that returns false. Okay. So this is a way, if you're programming, just Maybe you forgot the names of the built-in or the functions that go along with your object. It's easy to do, be it a list or a dictionary or a string. You can just call the directory function. Now, if you're using PyCharm, it's actually, you can not have to do that. If you just type the name of your variable and then a dot, then it will show you it'll show you all of the methods associated with it, and it will actually even show you kind of a brief definition of the parameter or parameters that you have to pass to it. Okay, but pretty much anything. Let's see, even things like numbers. So even the simplest possible variable, like an integer, it's actually an object, even though we don't really treat it like an object, we treat it just like a number. If you do the x dot trick in PyCharm, you can see all kinds of stuff that you can do with it. Okay. And see if there's anything that I recognize here. So I won't get into this. It gets a little bit complicated, but basically these functions are how you define. You can also define operators that work on things. So when we say x plus 4, this is actually calling a function that's in the object. That the variable object actually has an addition function, and that's what gets called when you do an x plus 4. So the neat thing is that you can actually define operators for your own classes, right? So if we wanted to, if we wanted to have our dog class and we wanted an operator called multiplication, we could actually multiply two dogs together, which doesn't make any sense whatsoever that I can think of, but you can do that, and it would make more sense in other contexts. But just an FYI that you can do things like that if you ever would have an interest in that or need for that, which I do talk about here a little bit. The less so again, if you have two numbers, and if you want to say is x less than y, it's actually calling a function on that object. Sort of, it's hidden from you, but it's doing that. And maybe it makes sense to have, is this dog less than this dog, where we would compare the weight or something like that, right? You could probably think of ways to use the equality operators in some fashion. If not for a dog object, then for something else that you've made. Okay, so that's the end of these notes. This is just sort of the barest minimum introduction to objects. There's entire huge books written about object-oriented programming. There's something called inheritance, where you can take an object and you can create an object that inherits the properties of another object. So you can have these hierarchies of things. So you could say a dog. You could have a class called mammal, and then you could have a class called dog, which inherits all of the methods of a mammal because a dog is a mammal. And then a mammal is, inherits from something else, like an animal, what have you. And that just means that when you create a new class, you don't necessarily have to do it from scratch. You can take advantage of another class that's similar. So you could have, staying with our dog example, you could have a dog class, which this is all the things about dogs. And then you could create a subclass of dog called poodle, which has some special things that only poodles have, like the fur, fur type or the you know, the special things that, you know, the poodle breed can do, or whatever. Okay, it makes more sense with other types of things probably, but we're not even going to get into that stuff because it's just, it gets too deep for an introductory class. Okay, so that's going to be it for tonight. And again, this is a complicated topic, so please, you know, don't hesitate to ask questions if you have them. And I will call it good for then, and I will talk to you later. Bye.